Okay, now we are going to learn this one, another method of integration for other type of question. So we have already learned this. This on all I say already, we consider this type number one. Very easy, you just differentiate this, then you can integrate the function. Okay, exponential sign become negative cos, cos becomes sine, and so on. Okay, and then if negative one become ln. Okay, but anyway you have to differentiate this and make sure what we have added here is a constant. This is type number one, the fastest and the shortest, the easiest. Next, then we come to integration by partial fraction, where you cannot use this method, but it can be the denominator can be factorized. Then you do the partial fraction like this. As long as you can factorize like this, then you use partial fraction. Then after that, we have integration by part, where you cannot use this, you cannot integrate. You cannot use partial fraction, then you have to use integration by substitution. So that's why you do all this first. And then now we come to the last one in our syllabus, that is integration by parts. Okay, what is integration by parts? Okay, we will come to that. Okay, first of all, you look at this. When you differentiate UV, I told you already, this is just like a house. We have two people staying inside. Okay, both these are variable, it's not a constant like 1, 2, 3. So when you want to differentiate, you differentiate this one, you differentiate the V, and then you differentiate the U. So when differentiate, you bring over here. When this bring dx, you bring over, this dx will come to here, this dx, and then this d will come here, become integrate. Integrate of this become uv. That means uv is, then this one can cancel, you get this, therefore finally you get this. So this formula is used when you are using integration by parts. Okay, so when are we going to use integration by parts? Okay, you look at this. Okay, we have already learned this. All these are all algebraic functions. So what I mean here, just now I show you this. Actually here, this is algebraic. That means the power. When we have the power, this is called algebraic. E is called exponential. And then all this trigonometric. This is called, okay, so we have algebraic, exponential, trigonometric. So you see we have this algebraic. Of course, algebraic is the power, include this one, the fourth one, the power. Here no power, isn't it? Exponential, trigonometric. So this is exponential, and then this is trigonometric. Okay, so when are we going to use integration by parts? Now you look at this. Let's say I want to integrate this. This is the combination of, this is power, isn't it? This is algebraic. This is exponential. Algebraic, exponential. But for this one, that means this is a combination of algebraic and exponential, number one and number two. So when you want to integrate this, actually we can use this method. Because why? X e x squared, this one you should know already, the bracket is here. You differentiate this, you get 2x, then you add a half. Then this is definitely correct. So it's a combination of algebraic, exponential. Okay, then later if you come to this one also algebraic, exponential. But here I change, instead of x squared, let's say I put 2x. So here also again, you want to integrate algebraic and exponential. So you want to integrate them. So what we have to do here, this one when you differentiate, you must have 2, isn't it? That means this x has to be pushed out. So when you push out, you see the x is red color already. So it's wrong already. Therefore this is wrong. Even though I can put 2 here, because I differentiate, divide by 2, I get this. But this is wrong. Why is it wrong? Not because of this. This is definitely correct. The mistake is here. You cannot have x outside. Okay, so in this case, how are we going to integrate x e to x? Like this one, okay, we can do it because we just add a half. But how to do? Okay, so you see this algebraic, this is exponential, algebraic and exponential. That's why we have to use integration by parts. So you remember, when there is a combination between 1 and 2, algebraic, exponential, you use integration by parts. So what is integration by parts? You look at here. Okay, I show you. Okay, first, you see I want to integrate this. This x is algebraic, this is exponential. So you remember here, because we are going to use integration by part, you must have this u dv equals to uv minus v du. So this is integration by part. So from here you must know which one is your u. So I tell you, the algebraic always your u, the algebraic one. So therefore the u is equal to x. That is the u. Here you compare this one with this, because I'm going to integrate this. So the algebraic is the u, and then the others, the rest is your dv, like that. The rest is this one. So always you take out the u first, then the remainder all are the dv. Okay, now so how? Here you see, that's why I get this. It's too small, that's why I write here for you. It's too small here, so don't look at this, you look at here. So here what I have to do, I must find what is my v. Okay, I want to use this one to integrate. So du dx is 1, so du equal to dx. Then here I integrate. So when you integrate 1, you get v. But here, when you want to integrate, the bracket is here, you must have a 2 here, you must have a half. So it's half e to x. So you see, this is the u, okay? This is the dv, this is the v, okay? So what we do here, you see, I substitute. The question is x e to x dx. So this is, just now I say already, is my u, this is the dv here on top here. that u dv. So I just substitute. So how you substitute? You just write down the formula like that. You put this bracket first. Then you remember, this one should be your uv, u dv equal to uv, v du, like that. You put down the bracket first, because here I cannot show you, I have already written everything. So u is x, you see or not? U is x, v is half e to x, v is half e to x, and then du is dx. That's why you get this. That's why you get something like this. So that's why we come to this. Same, isn't it? That's why we come to this. Okay, so I continue from here. Therefore I just show you. Then here you simplify. Then here half, you see half you take out, half I take out, and then because I want to here, okay, I show you. I show you again this part. This part half I take out. Then I want to integrate e to x dx, isn't it? This part. So because I want to integrate the e to x, the bracket is here, I still have another, I need to have another 2 here and half here. That's why I get 1/4, and then e to x, then plus c. That's why you see I have 1/4. You see I need to have another 2 here. Is it? That's why half, and then that's why I get this answer. So this is the answer. Of course, if you want to factorize, you can take out this, you can factorize to get this. Okay? That is how you do the integration by parts. Okay, I show you another example. Okay, let's say I have this. Let's say I have this. Almost the same one. Okay, never mind this part, don't look at it after I write here. Okay, now I want to integrate this x e negative 3x. Of course, I try to use this method. Let's see. I try to use back the method. Okay, integrate x e negative 3x dx. Okay, so you want to integrate this, the bracket is here, you must have a negative 3 here. So this x you have to take out. Now, so this is already wrong. Okay, yeah? This is, so this one differentiate, you get 3 divided by 3. So this is already wrong because the x is outside. So you cannot take the x outside. Okay, yeah? Therefore, this one how to integrate? Since you cannot use this method, you cannot use the method here. You cannot use integration by partial fraction. You cannot use substitution. You have to use integration by part. Why? Because it's a combination of algebraic and exponential. No partial fraction, no substitution, no integration by part. You cannot use this method. If you cannot use this method. So here you see same. Okay, here this is algebraic. So the u is equal to x. I told you already, always the algebraic is u, and then the rest is this. Then you can integrate this to get, okay, u I have, du equal to dx, this one also I have, and then here I integrate, I get v, here I must have a negative 3, I must have a negative 3 and a negative 3, and then divide by negative 3. So negative 1 over 3 e negative 3x. This is the v. Okay, then after that, I told you already, you write down, this is the question, x e negative 3x. Actually, this is the u, this is the dv, okay? So then you write down the 4 bracket first. That's why then you don't get confused like that. Then you write down, okay, this is u, v, then v du, you write, then only you substitute, okay, this is x, like that, u, you see or not, v, where is the v here, negative 1 over 3 e negative 3x, negative 1 over 3 e negative 3x, du is dx, so this is the one, therefore you will come to this, okay, then after that this is negative 1 over 3x, e negative 3x minus become plus 1 over 3, and then here you have e negative 3x dx, isn't it? Correct? Then after that you bracket here, you want to differentiate here, negative 3 at negative 1 over 3, so this is correct because you add only constant. Therefore when you integrate this one, when you integrate this, you will get negative 1 over 3x e negative 3x minus 1 over 9, is it negative 1 over 9, and then this one with this, with a negative 3 here, you can integrate this to get, to give you this. So answer, that is correct. This is called integration by parts. Okay, so now we go to the next one. Okay, let's say look at this. Now we look at this one. Okay, let's say I ask you to integrate this x, this is algebraic, sine, trigonometric, x squared plus 1, let's say I want to integrate this. This one, can you integrate using the first method? Usually we check with this method first. Sine, I want to integrate, I have to differentiate this, I will get negative cos. So I check whether I can use it or not. So you see, when I differentiate, this sine will give me negative cos. Okay, will give me negative cos x squared plus 1, is it? The sine will give me negative cos. And then I differentiate this. I get 2x. That means I just have to add a 2. Is it? Like that. So this is correct. This is 100% correct. Then negative half cos x squared plus 1 plus c. This is 100% correct. Now the problem is this now. Look at this. You have integrate, you want to integrate x sine 2x dx. So I show you again here. If let's say I want to integrate this x sine 2x dx. Now the bracket is here. So when I want to integrate sine, it will give me negative cos 2x plus c. But when I differentiate the 2x here, I will get negative, I will get 2. That means this x have to push out. So when I push out the x, I told you already, when you push out the x, what happened to the x? The x becomes red color. So it's wrong. Understand or not? So it's sine 2x dx. So here you must have a 2 divided by 2. So you have x over 2, but this x is wrong because this is already outside. So this is wrong. So that means this method already failed because we can only add constant. That means even though sine can become negative cos, but it's wrong because of x here. So what we have to do now, we use integration by part. Why do we use integration by part? Because this is algebraic, this is trigonometry. Just now is exponential, now I show you trigonometry. Okay, that is this one. It's a combination of algebraic and trigonometry. So just now I show you algebraic, exponential, now I show you algebraic, trigonometry. Later I will show you exponential, trigonometry. So it's like that, it's a combination. Okay, now you see, so this one, the u is equal to x. So we have this one. Then you differentiate du equal to dx. Another one, you have this one. Then I told you, after you identify your u, that is the algebraic, the rest is your dv. So it's sine 2x dx. Then you integrate them. Integrate. So the bracket is here. So you must have a 2 half. This is correct. This one v1. You integrate 1 is v. Then here you have half. Integrate sine, you get negative cos 2x. That means your v is negative half cos 2x, isn't it? Then the formula, this is your u, this is your dv. This is your u, this is the dv. So it's u, v, you write down the 4 bracket first. Then you can label so that you don't make mistake. U, v, v, du, like that. Then only you fill in one by one. U is x, v is negative half cos 2x, negative half cos 2x, and then your du is dx. Okay, that's why you come to this. You come to here. Okay, then you will come to here. Is it exactly the same? So we refer here. Okay, so after that, this one I simply take out. This one I take out the half, become plus. And then how to integrate the cos 2x when I take out. Okay, I show you here this part. Half I take out become positive, and then I want to integrate the cos 2x dx. When I want to integrate the cos 2x, I need to have another 2 here and divide by 2, isn't it? So it's 1 over 4, integrate cos will become sine 2x. Is it? That's why I need to have another 2 here. And then become 1 over 4 sine 2x. Same. Then plus C, that is the answer. Okay? Now we look at the next one. Now we look at the next one. Okay, how about this? You see this one. Let's say I want to do this. Okay, x cos 3x. Of course, you cannot use the first method. All those you need to use integration by part. Why do I say so? Because you see, when I integrate this one, okay, cos 3x, the x I have to push out. This x, I have to push it out. Why? Because here I must have a 3, then divide by 3. That is why you get x over 3, integrate cos, you get sine 3x plus c, which is wrong. This is wrong because of the x outside. So again, you have to use integration by parts. Okay, you cannot use partial fraction. Where got partial fraction like this? And substitution cannot. You cannot substitute because they are of different function. Algebraic and trigonometry. How to be the same? Just like different type of animals. Okay, so again your u is x. Okay, then du dx. Then this one, what we call the dv will be this one. So you want to integrate this. This one I write bigger. I don't have to show you again. And then after that, what you do? Okay, you remember, you write like this first. Actually here because here I have already written here. I can't show you what I did just now. You put the 4 bracket first like this, and then this is the definite integral with the limit. Then you put the limit like that, then minus, then integrate 0 pi upon 6, then like that. You write it like that. Then after that you do this step first, then you write down u v v du. Then you won't get confused. So you write down this one first, then only you substitute. Okay, you see the u is x, then only you substitute. The u is x, then dx is du is dx. Okay, from here, and then the v is 1 over 3 sine 3x, 1 over 3 sine 3x. Okay, that's why you will come to this. So actually all these I put the bracket first, then only I fill in. So I suggest you do, encourage you to do like this, because you are the first learner, so first time learner, so you have to do like this. So after that, this one, okay, 1/3 you can take out, and then here you get 1/3 as well, like just now, because I want to integrate this. This 1/3 is from here, the blue color one, but the red color is the added one. Okay, I added one because I need a 3 here to change this one into negative cos. So after that I get 1 over 3, then like this, then after that I substitute, then finally I get, okay, this one you know how to, cos 90 is 0, sin 90 is 1, so finally I get this answer. Okay, so this is the answer. Okay,